I'm Zach Kasperick, and I'm a power engineer in SEL's automation group. Today, I'd like to introduce you to our simple interface for configuring DFR solutions. I'll demonstrate how to quickly and easily configure standard DFR capabilities, such as capturing high-resolution fault records, logging SOE data, recording dynamic disturbance data, and calculating fault location. This wealth of data allows you to more easily monitor your system, investigate disturbances, and exceed compliance with standards such as NERC PRC 002. Today, I'll be configuring a DFR solution composed of an SEL 3350 RTAC and an Axion I/O platform equipped with a 24 digital input module and 2 AC protection modules, which will be connected to CTs and PTs in the substation. I'll configure this solution to monitor a transmission line asset using the DFR extension that's available in Accelerator RTAC software for project versions R152 and later. This is Accelerator RTAC software. I previously configured an SEL 3350 RTAC project type with an R152 project versions. Additionally, I've added my digital fault recorder extension into the RTAC project tree. First, I want to highlight a few of the general settings of the digital fault recorder extension. The first setting is the option to store DFR events in the SOE log. Setting this to true records the DFR digital and trigger conditions into the RTAC sequence of event log. The next setting is the option to enable our synchrophaser server. You can set this to true, which enables a PMU output for each configured substation asset via an IEEE C37118 synchrophaser server. The next group of settings is our continuous recording settings. Here we have the option to include our high-resolution 3 kHz analog channels from the AC protection module into the continuous recording group. Next, we have the data retention duration. For more information on continuous recording, check out our other how-to video on configuring continuous oscillography recording in the RTAC. The next group of settings is our triggered fault recording parameters. Here we can set our recording rate and our record length parameters. Next, we must configure our Axion node. I previously added a single Axion node, named it Node 1, and it's a 4-slot Axion chassis. If I click on the Node 1 sub-item, we can see that I've also added the hardware, which includes my power coupler, the 2 AC protection modules, and the 24 digital input card. I've also given these module names of M1 and M2 for the AC protection modules, and DI1 for the 24 digital input module. At this point, we can add a substation asset into the digital fault recorder extension. To do this, click on the DFR and click on the Substation Assets tab. Then we can press the Add Items button. Here we can add as many as 32 substation assets into the extension. I'm going to just add a single substation asset here. Next, we can give the asset a name. I'm going to name this asset Line 1. And then an asset type, and I'm going to define this asset type as a transmission line. Now I can save the Line 1 asset, which adds the Line 1 as a sub-item of the digital fault recorder extension. Next, we configure our Line 1 settings. The first setting to configure is our Line 1 voltage source. This can be set to none or any AC protection module in the project. I'm going to set this to equal to my M1 AC protection module. Next, we can define our current measurement source or calculation. This can be a single AC protection module or a sum of currents from 2 AC protection modules. I'm going to sum currents from my M1 module and the M2 module in this case. Next, we can configure our nominal voltage and our maximum load current settings. These values will be used for our voltage and current triggers in the trigger tabs. Next, we can enable our continuous recording. This adds the analog channels and the event trigger output of this asset into the DFR's continuous recorder. Last, we can enable our fault location. Setting this to true requires us to add our transmission line parameters, which then will be used for fault location calculations in the DFR. Next, I want to highlight the options for setting our trigger conditions for this line asset. First, we have our voltage triggers, overcurrent, sequence component, frequency, and power triggers. I want to set an overcurrent trigger. Here, I'm going to set my phase A overcurrent threshold to be 150% of my maximum load current. Additionally, I'm going to set a pickup time of 10 milliseconds. And then I'll save this. Now that I've entered all settings, I'll complete the configuration by clicking the Build DFR setting in the General Settings tab of the DFR extension. Setting this to true, the DFR extension now automatically adds the Axion I/O modules into the RTAC project. It takes care of all our tag mapping, adds the digital input information and settings for fault location. It configures all recording parameters for fault records, and it adds my SOE logs, the C37118 server, and the continuous recorder into the RTAC project. Now that brings us to the end of our demonstration on the DFR configuration interface in Accelerator RTAC software. For more information about SEL DFR Solutions, please visit our website and sign up for a no-cost, personalized demonstration. Thank you for watching.